So here we go again, another talk, and it's Einstein's special relativity, not a well-tested theory. And you probably need to say there's a question mark there, and we can conclude that Einstein's special relativity is not a well-tested theory. So I found this interesting video from a person who calls himself It's BS, and BS obviously means bullshit. So he's saying Einstein's relativity is bullshit, and I will only deal with one issue from that video, and it's the question of whether special relativity is a well-tested theory. So on the video he has a person who's a supporter of Einstein's relativity saying special relativity is a well-tested theory. The person It's BS disagrees with that and says it's not a well-tested theory. And so what now follows is a video clip.
The idea that special relativity is a well-tested theory is 100% wrong. In fact, there has never been an experiment to confirm special relativity. This is a very big, common mistake that people are making, and I'm going to explain exactly what I mean by that.
So the problem is what is meant by a well-tested theory. There are aspects of special relativity that have been tested, and such things as the Michaelson-Morley experiment, and that's said to be interpretable by special relativity. Now you could get on to an issue where dissidents start disagreeing with that, but the mainstream point of view is that the Michaelson-Morley experiment can be interpreted by the special relativity, so we leave that for now. And other experiments can be interpreted by special relativity according to the mainstream. So experiments can be interpreted by numerous different theories, and it's not usually the case that an experiment can only be interpreted by one unique theory. And the issue is called underdetermination. If you go to Stanford Encyclopedia of Philosophy, it explained as following: at the heart of the underdetermination of scientific theory by evidence is the simple idea that the evidence available to us at a given time may be insufficient to determine what beliefs we should hold in response to it, which means that you could do an experiment. It can be interpreted by lots of different theories, but you haven't got enough other evidence to decide which of those theories you should determine to use. And the person calling himself It's BS does not seem to deal with the issue that of underdetermination. However, he does deal with the issue that experiments can be interpreted by more than one theory. So get to that anon. Continuing on with the question of what is a well-tested theory, I would like to say that in order to well test a theory, would need the theory to be well defined, and special relativity is not well defined. The definition of what special relativity is ambiguous. So special relativity is usually taken as starting from this paper by Einstein in 1905. It's called On the Electrodynamics of Moving Bodies. And if you want to take it as defining special relativity, then I say it doesn't. I'm putting aside the other issues that I usually talk about in my other talks about saying that the paper has not been properly translated into English. It's still not properly defining a theory. Einstein in his paper says, "We shall raise this conjecture, the purport of which will hereafter be called the principle relativity, to the status of a postulate, and also include another postulate which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity c," and so forth. So it seems to be basing special relativity on two postulates. And so you might think, well, that defines special relativity. Unfortunately, it doesn't. I have known people say that these equations, the Lorentz transformations, are what define the special theory of relativity. Now, the usual claim by relativity believers is that the Lorentz transformations can be derived from the two postulates. In that case, both the Lorentz transformations and the two postulates might be assumed as defining the special theory of relativity. But Lorentz transformations can be interpreted by other things than just the two postulates. So if interpreted them by other than two postulates, would it then still be interpreted as special relativity? And also, if the two postulates can lead to different mass than Lorentz transformations, is that still to be interpreted as special relativity? And if extra assumptions are added to the two postulates, is it still to be interpreted as special relativity? There's numerous issues like this, and they're not addressed in Einstein's paper, so special relativity does not then become a well-defined theory. And that hits onto the problem with what its BS is going to say next.
Let's use Brian Greene's masterclass on the special theory of relativity as our reference. He uses the evidence that time dilation is what experimentally proves special relativity. Time dilation just simply means the moving clock slows. Let's listen to Brian and see if you can figure out what is incorrect about his statement.
Look, once you see that these two clocks show a different amount of elapsed time, you, I would think, should be convinced that these ideas are correct.
He is saying that if there is experimental proof that shows that moving clocks slow, then Einstein's special relativity is correct.
It confirms all of the ideas that we have described.
The main problem with his statement is that time slowing when moving is not unique to Einstein's special relativity. In 1887, Voldemar Voigt was the first person to publish this type of idea. This is Voldemar Voigt's moving clock in 1887, and it is equivalent to Einstein's moving clock in 1905. And then Lorentz also used Voigt's equations for his theory, and the name of the equation stuck with Lorentz.
So I quickly stopped it there because he uses the word prove, and the word prove can be a problematic word in science/physics. Often physicists like to say this sort of motto: no amount of experimentation can ever prove me right, a single experiment can prove me wrong. That's a phrase often attributed to Einstein, but there's usually a problem with checking that Einstein actually said these things, and I want to pass on whether he actually said that, because the main point is a lot of physicists go by that sort of motto. And what they mean by that is you can do many experiments that will agree with a theory, but can potentially do a single experiment that disagrees with the theory. And the single experiment that disagrees with theory is often taken to mean the theory is wrong, despite whatever number of experiments that agreed with the theory. So we have to put aside the problematic use of the word prove that the person it's BS uses, and just take it as a point as being that an experiment can be interpreted from numerous different theories.
Simple question. Why would Einstein's theory of special relativity be the only one to be proved by these time dilation experiments? All three of these theories have the same time dilation math. If you assume that Einstein's theory is the only correct one,
so putting aside the issue with the problem with the word prove, what he is really talking about is that time dilation experiment can be interpreted by more theories than just by special relativity. Earlier I mentioned underdetermination. Unfortunately, the person it's BS doesn't talk about it in terms of underdetermination. From the start sort of philosophizing using the term underdetermination, one of the usual things to do is to accept that an experiment can be interpreted by many different theories, but to then choose just one of those theories and ignore the other options, unless experimental results give a reason to swap to one of the other options. In the case of special relativity is chosen over the other options because Einstein brought that theory so much attention, and so then swapping to another theory requires justification from experimental results. So in a sense it's an arbitrary convention to go by special relativity, unless you've got evidence suggesting you should go by some other theory. However, as I mentioned, special relativity is not a well-defined theory. So when it comes to the different theories that the time dilation experiment can be interpreted from, these multiple theories are then often all thought to be special relativity, and thought of in terms of just saying things in slightly different ways. It's BS, however, thinks special relativity is a well-defined theory, as he next explains, but unfortunately it is not a well-defined theory.
then let's go ahead and apply time dilation to Einstein's theory. A unique feature of Einstein's special relativity is when he applies this idea of the principle of relativity to empty space.
So the problem here is when he uses the phrase unique feature. When he's talking about a unique feature of special relativity, its BS is going by Einstein's 1905 special relativity paper on the electrodynamics of moving bodies. And the problem with that is there have been a lot of changes since then. There have been a lot of changes made to Einstein's relativity, which I call moving the goalpost. I've done a lot of videos now on moving goalposts of Einstein's relativity. One of the issues is this: Einstein made mistakes, and it's pointed out in such books as this by a relativity professor. Believers in Einstein's relativity recognise Einstein made mistakes, and the way they respond to those mistakes is to try to make corrections, which I call moving the goalposts. Moving the goalposts is another reason why special relativity is not a well-defined theory. Einstein stated his theory in 1905, but people have made corrections to what he said and thus have moved things on, and then it's not a well-defined theory. So it's BS going by Einstein's 1905 special relativity paper on the electrodynamics of moving bodies hasn't realised that the relativity believers have moved the goalpost since then and are making it now not a well-defined theory, and that's hence why it cannot be well tested. It's BS carries on in his video to saying a lot of other interesting things, but I want to finish here where I've pointed out the problems he faces with what he said up to that part of the video. When he talks to a relativity believer that has moved the goalpost from what Einstein was saying in 1905, he's hitting problems because he's still thinking it's Einstein's 1905 paper and not realising things have changed since then. Finished, thank you.